Welcome to this combined Water Institute WaterTalk and Canadian Society of Exploration Geophysicists 2020-21 Distinguished Lecture, co-hosted with the Department of Earth and Environmental Sciences at the University of Waterloo. My name is Roy Blauw. I'm the Executive Director of the Water Institute, and I'm joining you here today from home, like most of you, I guess. I want to start by acknowledging that I'm living in the Untitled Tract in the Waterloo region. It's traditional territories of the First People and land that was promised to the Haudenosaunee of the Six Nations of the Grand River. The Untitled Tract is within the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. And I would like to encourage you to take a moment to recognize the traditional lands where you are. Before I introduce today's moderator, just a few housekeeping items. Please add your questions to the Q&A box, so not the chat box, but the Q&A box. And you can do this at any time throughout the talk, and my Water Institute colleague Nancy Goucher, who's also here with us, will help the moderator and get to those questions at the end. Just use the chat box for general comments or technical issues. The webinar will be recorded and posted to the Water Institute's YouTube channel afterwards. So at this point, I will introduce your moderator for the day, Professor Maurice Dussault from the Department of Earth and Environmental Sciences. Maurice, thank you very much for co-hosting this event today, and I'm happy to hand over to you.
Thank you very much, Roy. Today, it's my pleasure to introduce a University of Waterloo alumnus who did his master's degree here in Waterloo many years ago. We won't say how long. We're all trying to hide our age, including me. And Paul has done the majority of his career in Alberta, in Calgary, where he lives. But he's been all around the world, but particularly it appears, particularly in difficult circumstances. I mean, Yemen is not the easiest place in the world to work in. South Sudan, Kenya, and other places that are suffering humanitarian crises and water deficiency. So he has specialized in the geophysics, exploration for water resources, and also, of course, as any good geophysicist, he's also worked in oil and gas industry and mining industry and other related industries, because at whatever scale, geophysics is geophysics. So he's a senior person in advising in Calgary, and for about the last 30 years, he's been involved in this water exploration programs in water-stressed regions of the world. That means desert-type regions. Paul, as the distinguished lecturer for the Canadian Society of Exploration Geophysicists, I invite you to take command of this presentation and tell us what you've done in the last few years.
Thank you very much, Maurice. Thank you for that gracious introduction, and thank you everyone for logging in here. I know at this point in the pandemic, everyone's had a bit too much Zoom, but I certainly hope to make this here a while, and I'd certainly like to acknowledge the CSEG Foundation for organizing this this tour, and the University of Waterloo for hosting me. And I certainly want to acknowledge my Waterloo education. I think you'll see I was very fortunate. I had a fantastic advisor at Waterloo, Dr. John Greenhouse, and it was a fantastic time to be there, where I could carry out a graduate education in a very multidisciplinary fashion, integrating geophysics, groundwater, and all the various aspects of groundwater. And hopefully you'll see that education has served me and others well. Normally I give this talk in a very remote cabin in the loft, a small 400 square foot cabin with satellite internet, but today I'm in the basement, my basement in Calgary, so I certainly don't expect any internet problems. One thing I'd like to say, I certainly encourage anyone and everyone to put any chats or comments in the chat box for the CSEG. I'm supposed to create a bit of a diary, but given given that this tour is all being virtual, really the chat box is the only souvenir, the only record of the talk I have. Well, I'm certainly not afraid to broadcast how many years I've been working and how old I am. And because of that, we're gonna go back to the beginning of my career, which was in, well, I first got interested in both geophysics and hydrogeology, and that was 40 years ago in 1980. And after my third year, after my junior year in geological engineering at Princeton, I knew I was interested in the geoscience, but I wasn't sure what aspect. And I was fortunate to be able to line up a few internships in the Sinai Peninsula, that triangle of land between Israel and Egypt. And I took the year off, and for 6 months or so, I had what many might think is the ultimate geoscience job, where I was a support diver for a marine lab and an underwater marine lab. But after that, I was kind of keen to get on land and see the desert, and I had a 2-month internship mapping metamorphic geology in an area called Wadi Kid in the Sinai Peninsula. And of all the things I saw in that year, geological, the amazing reefs, the amazing tectonics in the Sinai, metamorphic petrology, what made the strongest impression on me was the Bedouins, these nomads in the Sinai, and their ability, without a Princeton degree, without any kind of education at all, their ability with complete confidence to site laborious and surefire water wells that they would hand dig in the middle of the desert, and in a particular area, Wadi Kid, where there's not even any springs. And after many cups of tea and sitting around the campfire, I finally understood that these Bedouins, they didn't have science degrees, they were great observers, they were great passes on of traditional knowledge. And they knew, for instance, that some dikes of a certain color were impermeable and would act as underground dams. Others were highly weathered, and they could dig into them, and based on the relief on the wadis, for instance, they knew where the alluvium was thickest. And I mentioned this to my interest to the lead geologist in this mapping group, Dr. Larry Gaber. And at the end of this program, he gave me this series of papers, and one of them was from the Israeli Geological Survey. It was about using what was then very basic geophysics, resistivity, simple resistivity, and simple seismic refraction to essentially mimic what the Bedouins were doing in terms of identifying dikes and depth of rock. And this completely captivated me, this ability to do non-intrusive investigations and identify water resources. And that's, to a big degree, that's what I've been doing for the last 40 years. And as Maurice mentioned, it's allowed me to go to some amazingly interesting and often difficult places, even countries I quite honestly never even heard of. But in fact, some of these places have been visited by people far more famous than me. So for instance, we're going to start with the Kokuma refugee camp, and this is a place where I'll be speaking about a water exploration program, but it's also been visited by two famous actresses, Reese Witherspoon and Angelina Jolie. And of the three of us, though only 2 of us have made a movie here in Kokuma, and Reese Witherspoon, of course, made the 2014, I would highly recommend it, Hollywood movie, The Good Lie. And in 2016, a documentary was also made of our water exploration program called Finding Water. But we'll also mention Angelina Jolie a bit later in the talk. Kokuma camp was established in 1992 for the 30 to 40,000 lost boys from the Sudan who walked across what was then southern Sudan for 1, 2, 3 years across desert, jungle, wetland into Ethiopia, and then fled civil war in Ethiopia to the border of Kenya, where UNHCR, the United Nations High Commission refugees, trucked these young, largely boys at the time, into the middle of nowhere, about 100 kilometers from the desert. And indeed, one translation in Turkana of the word Kokuma is nowhere. Today, there are about 80 million refugees in the world, and that includes 26 million or so official refugees, but another 55 million or so people that don't have official refugee status, internally displaced persons, asylum seekers, and so forth. So twice population of Canada. And most of these refugees, they're not coming to Canada, they're not coming to the States, they're not going to Switzerland. They're fleeing areas of ethnic strife, global warming, desertification, and they're walking to another nearby country that is usually only marginally better off. And today, in fact, Kenya is the country that hosts the 5th largest number of refugees. There are over 500,000 in Kenya, with about half of them in a camp in eastern Kenya, the Dadaab camp for Somalis, and then 200,000 in the Kokuma camp. And in Kokuma, the refugees are from 19 different countries, with about 60% from South Sudan fleeing civil war there, 20% fleeing civil war and desertification in Somalia, and the remainder is fleeing various types of ethnic strife or climate stress from Rwanda, Burundi, Eritrea, Ethiopia, Yemen, Chad, and so forth. The part of the camp that was first established when the Lost Boys came was Kokuma 1, and then as the camp expanded over time, there was Kokuma 2, 3, and here we're looking at one of the newer parts of the camp, the newer and, of course, more barren part of Camp Kokuma 4. On the left here, we have a geological map, a simplified geological map of Kenya. You'll see that peach-colored south to north lineament extending on the western part of Kenya. And this is the east arm of the East African Rift Valley. And the northern part of that Rift Valley system, you'll see two blue areas, and that northern blue area is the Loki Basin, sediment-filled basin, and Kokuma is in the southern portion of that. So being on the southern part of that, the rim of that basin, some places volcanics outcrop, some places it's a few meters below surface, some places the volcanics are several tens of meters but below surface. And the sediment is sand, it's clay, it's sand, clay, gravel, and then you also have a lot of salt deposits from the evaporitic lakes that would develop in these Rift Valley systems. And then on top of that, everything's been heavily faulted being in the Rift Valley. Since '92, UNHCR, United Nations High Commissioner of Refugees, have provided all the water from water wells drilled into the weathered volcanics. And when we did our program, the exploration program I'll talk about in 2016, all 12 wells supplying the camp were drilled into the weathered volcanics between depths of 30 and 120 meters. The wells were a variable yield, but all of those water wells produce water with fluoride concentrations at or above Canadian, Kenyan, WHO drinking water guidelines of 1.5 milligrams per liter. The water from these 12 wells, it's pumped out of the wells. It's pumped for 10 hours at night. The water is chlorinated and then put into these 10 or so overhead 100 cubic meter tanks. And then the next day, hopefully, for a few hours in the afternoon, a few hours in the morning, water is fed by gravity to hundreds of tap stands scattered around the camp. In the morning, young people, refugees, mostly young children, mostly young girls, will line up with their jerry cans in the camp, hoping the taps will run, hoping they won't be physically abused, hoping they won't be raped, hoping they'll get water and maybe be able to get home and get to school. So of course, many of them become discouraged. They go out into what are called lagers in Turkana, these wadis, ephemeral riverbeds, and they'll dig what they call scoop holes, gather some water, take it home. And needless to say, this water is high in E. coli as well as other pathogens. As difficult as the water situation is for the refugees, it's even more challenging for the Turkana, the host community people whose lives revolve around taking their herds of donkeys, camels, and goats from one ephemeral water source to another. So I was in Kokuma camp for a couple weeks in 2014, and again in 2015, I created and taught a short course on introduction to hydrogeology, introduction to water exploration, geophysics. I left geophysical equipment, trained the refugees on that, introduction to drilling, manual drilling, hand pump repair, and so forth. During my time in the camp, I certainly became intimately familiar with the water system, and I came to two conclusions. One, that there wasn't nearly enough water, and the other, that the water was not of good quality. So I thought, I didn't know, but I thought maybe I can I can do better. Maybe I can improve on this. So in 2016, I got a grant from Geoscientists Without Borders, and I came back to Kokuma and I put together an exploration program, staffed almost entirely with a few colleagues from Calgary, and then with students from my previous programs. And I'm just going to introduce you to a few. This first one is Loki Louie, and she's a Turkana woman. She's actually a teacher at the Angelina Jolie Primary School, and this is a school that Angelina Jolie established, a boarding school that offers an alternative to early childhood marriage to young girls. And like all the students, 40 or so students in the program, Loki spoke at least 3 languages: Turkana, English, and Kiswahili. Laban Lucero, he was a child soldier in South Sudan, very good with a machete, which certainly came in handy in the program. And like all, again, he spoke 4 different languages. Junior Kayembe was 3 years into a geology degree in the Democratic Republic of Congo, and Civil War broke out, and he fled by hitchhiking on foot to come over 1,000 kilometers to the Kokuma camp. And he actually recently received 3rd country repatriation to the US, where he's working as a translator, and he speaks at least 5 different languages. So my strategy was pretty simple. As I said earlier, the UNHCR had targeted all their wells previously into the volcanics from 30 meters to over 120 meter depth. So I thought, instead of looking in these volcanics that not only produce variable amounts of water, but all produce water high in fluoride, because fluoride comes out of calcium fluoride, which is a common mineral associated with these Rift Valley volcanics. I would target paleo wadis, paleo lagers, these dry riverbeds that perhaps existed, perhaps would underlie the camp, perhaps would intersect with these existing large lagers, Laga Nabek and Laga Tarash, that bracketed the camp. The idea being that these would be filled with sand and gravel. They would produce more water. They would produce better quality water, because the aquifer would not be these weathered volcanics, and they would be less expensive wells to drill. But of course, what's missing here is there's no water. But I knew from being there in the fall for 2 years, that for a week or 2 every fall, and then a week or 2 in the spring, as you can see in the hydrographs on the left, when you get enough days of consistent rainfall, as typically does happen a little bit in the spring and the fall, what they call the big rains and the small rains. If it rains for enough consecutive days, you start to get water accumulating in the lagers, essentially flash floods. And I knew also from limited hydrographs that were available, as you see below, in hydrographs from 7 of the 12 water wells, it's only 7 that were available, that these water wells in the volcanics, the water levels responded immediately. So from that, I assumed that then overlying sands and gravels, if they existed, would also respond immediately to recharge. So tactically, we used 2 techniques for this water exploration program: seismic refraction and 2D resistivity. With the hypothesis here being that seismic refraction, of course, simply measures the velocity of the subsurface. And pretty much anywhere in the world, bedrock is fast, overburden is slow. So the seismic refraction would allow us to identify the top of rock from that higher, faster velocity contour. And from that, we could determine where the overburden was thickest. And then we would use the 2D resistivity to determine whether the overburden consisted of low resistivity, that is conductive, clays, silt, saltwater saturated sands and gravels, or if the overburden was resistive and consisted of freshwater saturated sands and gravels, as is our target. So we collected 14 kilometers of resistivity, 8 kilometers of seismic refraction in 2 weeks with the Refugee and Turkana crew. And here you see the first section on which a well was drilled. It's an 800 meter long section, 70 meters deep. I've pulled off the top of bedrock from this 2,000 meter per second contour from the refraction. And then overlying that, we see our resistivity section. And we can see this hot pink layer, this high resistivity blanket of what we interpreted as sands and gravels. And this became the first target of a UN well drilled about 2 months later. And that was Lucky Borehole 13. It was one of the shallowest wells ever drilled, screened between 14 and 29 meters. It was also one of the most productive wells ever drilled, producing water at 40 cubic meters an hour. And it was also the first well ever drilled with fluoride concentrations below drinking water standards at 0.9 milligrams per liter. The UN then went on to drill 2 other wells in nearby sands and similar resistive sand and gravel deposits. These wells were also good producers, 29, 45 cubic meters per hour, also low fluoride. And to give you a better sense of how much water is, these 3 wells alone, pumping 10 hours per night, as is the habit of the UN, as the practice of the UN, and targeting 20 liters per person per day in the camp, produce enough water for 60,000 refugees. And these 3 wells are still pumping today. So I'm sure everybody out there, would agree with me that finding water for 200,000 refugees stuck in the middle of the desert is a good thing. There's nothing wrong with that. But really, how important is it that the water meet these guidelines of 1.5 milligrams per liter fluoride? Well, in 2018 and 2019, for the first time ever in the history of the camp, a dental clinic was established for 1 week by a small Israeli NGO, Israel Aid. And as you can imagine, after 25 years without dental care, the dental clinics saw only the worst, the patients with the most severe conditions. And the dentists reported that they did, each of those weeks, they did over 200 extractions. And of the more than 400 extractions, dental extractions done, about 70% of those extractions were directly due to dental fluorosis. That was certainly from drinking water in the camp. So it's probably no surprise, as Maurice mentioned, that areas in the desert are water stressed. But what we're starting to get a better worldwide global picture of is, in fact, aquifers everywhere are stressed. And this is particularly coming out of the GRACE satellite pair that's giving us continual gravity maps of the Earth. And what's changing and what's creating gravity lows? What's changing the Earth's gravity? Well, 2 things: melting ice and depleting aquifers, at least on the scale that GRACE is looking. And in fact, GRACE has told us that 2/3 of the 30 or so large regional aquifers in the world are at major stress points, and indeed are at or beyond tipping points. And it's not just an arid area. So here, for instance, looking at the Indian subcontinent, and the yellow box is over Bangladesh. And Bangladesh receives more than 50 billion cubic meters of groundwater recharge a year, but Bangladesh extracts 53 billion cubic meters a year. If we follow that yellow arrow, that takes us to the southern part of Bangladesh, southeast part. And this is the Teknaf Peninsula. And it was here in the Teknaf Peninsula that, beginning in August 2017, more than 1 million Rohingya refugees came on foot and by boat, fleeing ethnic cleansing, genocide, and mass murder in Myanmar. And in fact, it rains a lot in Teknaf. The average rainfall is 3.8 meters a year. To put that in perspective, that's twice the rainfall of one of Canada's most rainy town of Squamish on the BC coast. So following our success in 2016 in Kokuma, UNHCR invited us to do water exploration in Teknaf. Of course, these million refugees needed water. About 10 refugee camps that were established and worked all over the peninsula, but we focused our efforts in the southern part of the peninsula. Up to then, it was known there were only these thick sequences of the Bocabil shale. And indeed, we found, as you can see in these 2D resistivity sections, and as identified by the high resistivity red zones, we identified a number of incised sandstone aquifers incised into the Boca Beetle Shield, and wells were drilled, water was found, and the flow rates varied from 10 to 20 gallons a minute, so 4, 5, 6 cubic meters an hour. So this is a significant amount of water, but not nearly enough water for 1 million refugees. At the same time we were doing this program, there was essentially what a very chaotic and uncoordinated response going on from quite literally hundreds of NGOs, aid organizations, religious organizations, and other UN agencies drilling wells without any regard to geology or any type of mapping or other types of input, essentially just putting wells wherever they felt there was space to drill a well. So, of course, many of these wells, and when I say many, thousands, well over 3,000 of these wells were just simply very shallow hand pumps, suction pumps that would target water sources in the top 5 or so meters. And to get some idea of the chaotic response, here you can see 2 wells immediately next to each other, with one with waste water, untreated wastewater flowing from one well into the other. And needless to say, with well distributions like this, as the dry season came, immediately following the wet season, most of these thousands of shallow wells went dry. And an even worse situation developed beyond actually running out of water was that many, in fact, most of these wells were placed without any regard to point and non-point sources of contamination. So for instance, here we have 2 wells amongst the outhouses and shower stalls and areas of open defecation and overland runoff. So I actually came away from this program very discouraged, and focused my my next humanitarian project on a part of the world where there weren't NGOs, the UN wasn't present, and even the national government had largely walked away from. And this is an area of northern Uganda called Acholi land. And here I received another grant from Geoscientists Without Borders to carry out a community water supply program. From 1982 to about 2006, 2007, Joseph Kony and the Lord's Resistance Army prosecuted what became Africa's longest running civil war. In the course of this civil war, the government of Uganda, which is the present government of Uganda, took advantage of the situation. And generally the consensus is they used this situation to attempt a cultural genocide of the Acholi people, and use the civil war as an excuse to clear the landscape of the Acholi villages, to ostensibly open up a battlefield against the Lord's Resistance Army, the LRA. And they put almost 2 million Acholi people into 251 what they call protected camps. But these are essentially concentration camps where one would find literally the highest mortality rates in the world, 1,000 people a week dying from horrible diseases like Ebola, AIDS, malaria, cholera, dengue, and so forth. UN agencies, NGOs, church organizations were very involved in running these camps, essentially enabling the camps. But as the Civil War wound down in 2006, 2007, all these aid agencies left. People were largely on their own to return to their villages. Families at that point in the war consisted largely of elderly women and young children. Of course, they had to rebuild their gardens, they had to rebuild their homes, and they had to rebuild their water. So geologically, where is Acholi land? Well, in northern Uganda, Gulu is the largest town. We're not that far from Kokuma, about 300 kilometers to the west, but a completely different geological environment. We've come out of the Rift Valley, and we're now onto the African crystalline basement that covers about 40% of sub-Saharan Africa and is home for about 50% of the population of sub-Saharan Africa. Think of the Canadian Shield in a much warmer climate. And where do you find water here? Well, I had a pretty good idea because in 1999 and 2000, I carried out a water exploration program with my colleague, Richard Kellett. This program targeted 450 water wells. It was a German development bank program to identify drilling locations in southeast Malawi, both in the Rift Valley and in the crystalline basement terrain. And we went into that program not set on any one particular method. The first thing we did was identify 20 water wells, long producing, steady producing hand pumps that had produced for a long time, but weren't producing at that time because of mechanical problems with the pumps. So we pulled the pumps, and while the hand pumps were out of the wells and being repaired, we then carried out borehole geophysical logging programs in the PVC cased boreholes. And we logged natural gamma, conductivity, magnetic stuff. We're looking for what physical property would distinguish the aquifers, the water producing zones in these wells. And where do you get water out of these crystalline basement aquifers? So generally you get it out of what's called saprolite. And saprolite is crystalline rock, whether it's diorite or gneiss or granite. But after millennia of being subject to intense rainfall and warm temperatures, you begin to get dissolution of the soluble minerals. The rock preserves all its texture. It still looks like gneiss or granite, but now it's saturated and it has pore space. And what you can see from the logs presented in front of you is that the log that most diagnostically identifies that saturated saprolite zone is the conductivity log. That these saprolite zones are more highly conductive, much lower resistivity than the laterites above, or the sap rock and crystalline bedrock below. So in that program, we used electrical methods, and we applied electrical methods again in Uganda. So here again, Uganda, I'd also been doing training programs in 2015 and 2017 with the Choli people. And unlike the refugees, though, refugees can be sheep herders, but they can be geologists, geophysicists, airline pilots, and yoga instructors. I've met them all, but in Choli land, here the IDPs, the refugees, were largely either child soldiers or they'd been born and grown up in the camps with very little education. But nevertheless, they were smart people, and they learned extremely quickly practical aspects of what we were doing, and a lot of the theoretical aspects. So we largely used 2D resistivity as our main exploration program. Again, I put an exploration program of 20 villages together with the Choli people as my crew. I'll just show you a couple sections. Here's one section in the village of Dure, 500 meters across, 60, 70 meters deep, a resistivity section. On the right, on the south part of the section, we see the more highly resistant material, the warmer colors rising to surface. And on the left, we see our target, blue. In this case, the more conductive, less resistant material in contrast to Kokuma. And this is our saturated weathered saprolite that would serve as our target. Myself and a few colleagues from Calgary, we served to guide to help with the geophysical program. And then we stayed to help interpret the geophysics. But at this point, the Acholi people knew much more about manual drilling and pump installation than I did. So in order to be certain that the wells were drilled in the proper locations, we assisted in interpreting the data. We created drone orthophotos, which always was great entertainment in the village, and then cited the drilling locations in coordination with the Choli people on the orthophotos. So even without GPSs, even without good maps, the wells would be drilled in the proper location. Then within a month or two, the Acholi students followed behind with these manual methods, which quite impressively, you can get through 25, 30 meters of crystalline rock in 2 or 3 days using these labor-intensive but quite effective mud drilling manual methods. I'll just show you one more section that's a little more complex geology. Here you see the brick red highly resistive laterites at surface, the crystalline, massive crystalline unweathered rock at base. And then we have the section split by a vertical dike. And you can see there's no evidence of it in the air photo. It just happened to be in the middle of the section. And very much as those Bedouins in Sinai used their traditional knowledge to identify those dikes as underground dams, we use resistivity to do the same thing here. We could clearly see that the more conductive part of, there was an upgrading, more conductive part of the section where the saprolite, the aquifer, was saturated, and the down gradient part of the section, down gradient from the dike, the resistivities were much higher, indicating an unsaturated saprolite layer. So again, the Acholi students we interpreted the data, they drilled the hole, manually drilled the hole, install PVC casing, install here a cylinder, the piston is installed for the manual hand pump, what's called the rising main is being installed. All the Acholi students are very capable of doing field water quality measurements. We also took water samples for laboratory water quality measurements back in Canada. Of course, we wanted to be certain that we're supplying good quality water. Manual hand pump is installed, and then a cement apron is installed. And that's very important that you have good drainage at these sites. You certainly do not want these hand pump wells to become epicenters for Zika, for malaria, for dengue, for other mosquito-borne diseases. Having met hundreds of refugees, and especially having spent a lot of time, 4 episodes at the Kokuma camp, I'd met lots of refugees from South Sudan. I'd heard many stories of mass murder, of human suffering, of the violence that had occurred and was ongoing in the civil war in South Sudan. Needless to say, I certainly was not going to, would never work in South Sudan myself. But in October 2019, last year, but actually almost a year ago exactly, the ICRC, the International Committee of the Red Cross, contacted me, and they said in the northern part of South Sudan, deep in the Sud wetland, which was the ground zero for the civil war, there was not a peace agreement, not a truce, but a cessation of hostility that allowed them to get in to develop water supplies for some of the more remote villages that had been cut off from the civil war. So they wanted to know if I would carry out such a program, and of course I said sure. So here we have a simplified geological map of South Sudan. Again, we haven't gone very far from Gulu to Juba, the capital of South Sudan. Is only 300 kilometers. You can see that taupe area is just a continuation of the African crystalline basement. But then you move north into the Civil War area and the refugee area, the Sud, this wetland. And this is a vast wetland underlain by quaternary and tertiary sediments of unknown thickness. Certainly likely mostly silts and clays, low energy sediments. And to get from Juba up into these remote areas based around a couple of small villages of Hatton Shore, we had to reach those by helicopter, Bell 412. So pack the Bell helicopter with lots of gear, as well as drinking water and food and any tents and sleeping sacks, and away we went. And we flew over for 3 hours over the wetland that was not only wet, of course, being the type of terrain it is, but was also undergoing unprecedented flooding during that particular period. And a month or so later, when I got back to Calgary, I actually found it quite darkly humorous. I saw this news, trending news newscast from BBC, and I heard similar colleagues at the AGU, the American Geophysical Union conference in San Francisco, contacted me with the similar information, similar story, where a paper had presented at the AGU that identified the source methane concentrations that seem to exceed any of the world models that were going on for methane concentration in the atmosphere. And the source of that seemed to be small discharges of methane coming out of the Sud that were due to the flooding. And I found this darkly humorous because to me, this was not a story. The real story and the unreported story was the massive flooding, the accompanying famine in the midst of this civil war and mass human migration that was going on in this country of just 8 to 9 million people. So similar to Kokuma in Uganda, of course, I did drone imagery over all the villages that we carried out, all the 20 or so villages where we carried out water exploration. Again, to be certain that the interpretations, the locations of the interpreted targets would be perfectly placed. Certainly something I assume everybody immediately notices here, that there's a lot of water. Now, of course, this is the wet season, it's in the middle of the flood, the water levels do drop, it's more difficult to access this river, which is a tributary of the Nile. And you do have lots of crocodiles in those wetlands. But the real issue here is that there's no sanitation, open defecation. You have cattle openly grazing. All the surface water sources are full of E. coli and other pathogens. So groundwater really is the only safe, sustainable water source. So from the two villages we based out of, we carried out long treks into the outlying villages, hiring all female porters, using our 2D resistivity gear, with the porters carrying the batteries, cables, electrodes, electronics, very, very heavy loads through waist-high, razor-sharp grass, through knee-deep mud, 45, 50-degree heat, lots and lots of mosquitoes, tough terrain. And where we would target even further outlying villages, the Red Cross supported me with amazing logistics. We had 2 boats that would allow us to get as close to the villages as possible, and from there we would walk. And again, we use this technique of 2D resistivity. And here we're looking for resistors, sands and gravels that would be aquifers within these thick clays and silts that comprise the Sud wetland. And as you can see from this first section and the number of first few sections that we ran, all the resistivities are very low. Cool colors, blue and green, less than 7 ohm meters. There's not a hint of anything resistive, any granular material. But as we carried on, eventually we did find sands and gravels, indications of sand and gravels in almost every village we target. So here we have a 600 meter section looking about 7 meters deep, and that hot pink layer just really 5 to 10 meters below surface is almost certainly a sand and gravel channel blanketing across the site. And the Red Cross will be targeting these sand and gravel channels with either manual drilling methods or even hand digging methods, because they are very shallow. They're simply waiting for the pandemic to subside so they can safely go into these areas, and hoping, of course, that the peace will hold. When I came out of the wetlands, when I came out of the Sud, out of Jonglei State, I came to Juba, and came in on a Friday evening. The helicopter landed, and the Red Cross had 3 items for me. First, they had a gin and tonic, and then a second gin and tonic, and then they gave me a map of the neighborhoods of Juba. And asked if I do a little more water exploration within Juba itself. Juba is an unusual capital city. There's no centralized water system. There's no grid power system. There's no waste sanitation system. And this map, what this map shows is color coding of the degree of waterborne diseases, and you can interpret that as cholera. And the darker colors represent areas that have more outbreaks of cholera. And it's known that there's an inverse correlation with water supply. Where you have more water, you have better sanitation and hygiene, you have less cholera. So for a week, I carried out a number of 2D resistivity sections exploring for water within the city of Juba. I'm just going to show you one of those sections. This is a neighborhood that actually is right downtown, the Sant Augustine neighborhood. And this well was placed here by an NGO because it's at the intersection of two roads. But logistics access isn't always a good criteria, because any geologist in their right mind, including myself, would certainly identify this as a terrible target drilled right into the massive crystalline rock. But in fact, it's a good target, and the geophysics tells us a different story. We can see that that rock that looks massive isn't so massive. The resistivities are very low. That blue blanket of rock, less than 50 ohm meters, it's clearly saturated saprolite. But we also see out of this section is that 100 meters to the west of that hand pump, we see even a better target that will provide a second well to this heavily used area, heavily populated area. The saprolite's twice as thick. We'll have twice the drawdown. We'll have a well that will likely be far more sustainable during the dry season. In conclusion, in summary, I'd like to step back about 15 years actually to 2005. I worked through in the 80s for 5 years in Indonesia. I speak Indonesian, speak Malay. Thanks to Waterloo, I have a good background in both hydrogeology and geophysics. So in the 2004 Boxing Day tsunami, UNICEF seconded me to assess the impact of the tsunami to Aceh province, where 170,000 people in Aceh province alone were killed, and to begin the redevelopment of water supplies there. And I took this picture myself from a contraption I put together, suspending a kite from a camera. And cool photo, of course, it's showing a tugboat that was pulling a coal barge from South Sumatra up to Singapore. It was captured by the tsunami wave, lifted and dropped onto the only coastal highway. But that's not why I took the photo. The reason I took the photo is this location was one of the first places that US Geological Survey scientists came to measure the height of the tsunami wave from the denuded escarpment behind. And the wave was 31 meters high in this point, over 100 feet. Of course, the wave completely inundated the coastal plain and in fact caused flooding as far inland as 5 kilometers. So something I saw that other colleagues I know saw all around the Indian Ocean. This photograph, for instance, is from Sri Lanka. Everywhere I went, I saw aid organizations, UN agencies, religious organizations, whatever, descending upon the various villages, and in Aceh province alone, installing these pumps in some of the 200,000 wells that were inundated, pumping the salt water out of these wells, more forcefully drawing in the saltwater intrusion front, discharging the salt water back onto the land surface immediately adjacent to the wells, continuing to pump, usually until the wells themselves collapsed. So the conclusion I hope you get out of that photograph and from this talk is that humanitarian crises that have happened in the past, that are ongoing now and will happen in the future, they all require considerable amounts of funding. They all require considerable amounts of human intervention and often very complex logistics. What they also require and very rarely receive is some really good, just basic scientific input and almost always some good geoscientific input. So hopefully everyone out there, especially students out there, will realize as they're potentially nodding off over their petrographic microscopes, as I often did, or at field camp, trying to master some of these fairly arcane field techniques that certainly I learned at the Waterloo Field School, that there actually is a lot of practical value to both the education, the basic knowledge, and the field methods, and that your educations really are of great value in addressing some of the most pressing humanitarian crises that the world is facing now and will face in the future. I'd quickly like to thank the CSEG Foundation for supporting this, Geoscientists Without Borders for funding the Kokuma Uganda programs, my colleagues in Kokuma, Refugees, Turkana, Chole crews for staffing, for doing the actual work, Israel Aid, providing logistics in Kokuma and Uganda, International Committee of the Red Cross, and Groundwater Relief supporting the South Sudan program. So Asante Sana, as they say in Swahili, this is actually from the Kokuma camp looking out into the Rift Valley across the volcanics. And very quickly, I'm just going to flash a few CSEG slides from the CSEG Foundation. Of course, it's supportive of this lecture and is particularly supportive of outreach programs, of student programs, student scholarships, and you can get all this information and more from the CSEG website, which is here. The address is on this last slide. And finally, I'd like to thank everyone who have stayed through this talk. It's the first talk I've ever given that there's actually more people at the end than at the beginning. And I'd certainly be happy to answer any questions.
Well, thank you very much, Paul. What a life you've led. Wow, I'm kind of blown away by what you've done. And when I was young, I was partly raised in the Northwest Territories in First Nations communities. And as you know, we have an ongoing boil your water advisory in many First Nations communities in remote locations. What lessons have you learned that you can teach us here in Canada, our politicians, our First Nations communities, and technical people like me and others that are listening with this water crisis? What lessons can us?
Yeah, thanks, Maurice. That's a great question, and it's actually I'm always surprised it's a question that's really asked. You know, I go to Uganda, I go to Kenya, and of course we have these water crises here in our own country, and some people, and I would think some people even ask, why aren't I doing work here? And in fact, I've certainly done a number of water programs at First Nation reserves here, but here it's very different. I mean, it's a very different situation. Now here, I very much like a lot of the humanitarian work I do because I go to places like Kokuma and it's non-political, it's non-religious. I don't even know I can't even tell the difference if I'm a Dinka and a Nuer and a Christian or a Muslim and certainly in whether it's in South Sudan or in these refugee camps. All I know is that these people are in desperate need, and it's really just a question of life and death. And in Canada, you know, clearly these problems we're facing, and I would say, even to put it euphemistically, would be to say that they're political problems. Clearly, we're a rich country. We can solve these water crises problems, and of course we know when we have a water quality problem at Wakaton or cryptosporidium outbreak in the Okanagan, it's front page news, and most of us never hear of any of these reserves, these native communities, until there's a water crisis. And I say euphemistically it's a political problem because really a phrase that's used more and more recently is systematic racism, and it's hard to really pinpoint to anything other than that why we can tolerate these poor water situations in these communities. Now there's certainly, you can break it down beyond that, though. Of course, you can break it down into technical problems. Some of these, I think they're now well below 100 communities that have boiled water advisories, but nevertheless, these communities, some of them have problems with the water sources themselves. Some of them it's technical. They don't have the treatment facilities, or the treatment facilities aren't well designed, or they're not well operated, or they're not well maintained, or so forth. But again, beyond these technical problems, you know, really what it comes down is to political and sociological problems of the country not supporting the educational and the basic humanitarian needs. But Nellis, I'd like to tie it a bit more, and maybe more directly answering your question is something, hopefully a thread you saw through the progress of my talk is over the decades I've done some of this humanitarian work, and in the big picture I found it very frustrating working with big agencies, UN, or even under the control of these big agencies like the UN or even governments. And I found it not only much more satisfying, but often much more effective, as you saw in Acholi Land, where there is no UN, there are no NGOs, there is no government involvement, working with the people in the communities, working from the ground up. And something I didn't mention, but those 40 or so Acholi students that most of them had no education. Not only did they truly do most of that work, but since these training programs, they've gone on to establish their own drilling, hand pump programs, exploration programs. They've got contracts from UN agencies. They're doing water programs in Ebola camps and in the Congo and IDP camps in South Sudan. And it really can work, working from the grassroots up, which isn't to absolve government from the things that they're responsible with, but I think giving Native communities, truly giving them tools they need, they can solve their own problems, and they don't have to be dependent on government aid, government interference, government programs, which we know even in the South are often rife with all kinds of problems. So that's probably the main lesson, is that don't just look from top down, but bottom-up solutions.
Oh, thank you. That was a long answer, and basically, paternalism doesn't work, is what you're telling us as well. Thank you. I'm going to read some questions from the question and answer box. I think you can open it yourself, Paul. What advice would you offer to young people who want to get more involved in humanitarian work?
Yeah, well, I guess the big picture, I'll give it, hopefully I won't give too long an answer to that, but the big picture, the first thing I would say is, if you are interested in this and you get an opportunity, take it. Like, don't not take it because you're not sure if it's safe, or you don't know if you have the time, or you might have to take time off from work, or that kind of thing. You get an opportunity, take it. If you do want to do this work, you really have to actively pursue it. Surprising as it might seem, aid agencies and the many NGOs working in what they call the WASH sector, the water, sanitation, hygiene sector, they're not looking for educated people. They're not looking for scientists. Generally these programs are run by people with community health backgrounds at best, and usually, some very basic water quality background. And part of the problem is they really don't even know what they're missing. How do you look for this type of opportunities? Well, probably the single best piece of advice I could give you is look on the web. And there's many websites, but there is one website that is the best website, and that's called Relief Web. And that's run by OCHA, the Office for Communication and Humanitarian, I think, 8 assistance by the UN. And that has a constant list of, it's easy to search by theme, and you can find geophysical programs, or water exploration programs. There's a whole WASH sector, and there's always hundreds of jobs posted and 100 volunteer opportunities. And yeah, so those are the main pieces of advice I can give you right away.
Michael asks, are your data, you're generating a lot of digital data, are your data somehow being archived, preserved, and to be used for the future?
Yes, absolutely, as much as possible. And I always do everything I can to make things as public as possible. Like, for instance, I often use the recorder, like both the Malawi program and the Bangladesh program. We had articles in the CSEG recorder, with the main advantage of the recorder being it's completely available in the public domain. I do everything I can possibly do to provide data to local government agencies, UN agencies. I remember at the end of the UN program, this is in 2005, I made a zillion CDs and got a motorcycle taxi and just went from NGO to agency, just delivering the CDs, and sat with the OCHA people again to make sure it got on their website. So it's not always easy, but I not only do I make a point of doing that, but I would say, in the short term, these aid agencies, they don't think it's important. They say, look, people are dying, we need water. It's about, data sets. But in the long term and medium term, I would say it's critical. Otherwise, you don't learn from the mistakes, you don't learn from the successes.
Okay, with respect to reaching out to groups and the website that you mentioned, if anyone wants to get into contact with Médecins Sans Frontières, I have a colleague who was the Canadian head of that association for a couple of years, and her husband worked for them as well as a logistics manager. And I wanted to offer that link to anybody who really wants to contact Carol, and he can tell you about logistics issues in Médecins Sans Frontières, because I want to weave that into your question, Paul, or your concerns, Paul. Logistics. How do you handle that in Aceh after the tsunami? Gosh.
Yeah, first of all, one little thing I'd like to, that Médecins Sans Frontières is a nice example, because so many times their wash programs are run by their logistics people. And
yes,
the same person that knows how to dig a latrine and set up communication and set up a dining hall and organize transport doesn't necessarily have the most in-depth knowledge of the hydrogeology of the African continent, or how to drill a water well, or how to run a pumping test. And they do the best they can do. And it also actually is interesting, Médecins Sans Frontières, I was in Aceh during the tsunami, and Médecins Sans Frontières it was probably the crisis that changed Médecins Sans Frontières, not getting the Nobel Prize, but the money just poured in and poured in and poured in, and there actually weren't that many people that needed doctors, because in the tsunami, people either lived or they died. And so they had way more money than they could know what to do with, and that's really where they started, getting drill rigs and getting involved in the WASH program. But yeah, logistics are huge, and that's why for instance, most of these programs were 2-3 weeks a month, but the amount of planning that goes in is just massive. Except
right.
a crisis situation, like for instance, South Sudan program. But there, I took advantage of ICRC, and ICRC, Red Cross. I mean, they have more. South Sudan doesn't have. They have their own air force. They have their own army, their own navy, and logistics are critical to all these programs.
So you're suggesting that you reach out for help wherever you can, and if there's any Médecins Sans Frontières or Engineers Without Borders or any group organized that is working there, they have had their own logistics issues and they can help you if you're doing humanitarian work in the region.
Yes, I would certainly recommend anyone that's wants to work at things at Geoscience. Find someone that's an expert in logistics, expert in the community relations, that has on the ground. To not only is that essential, but you really, when these kind of situations, you really want to be focused on what you're doing. Like, you're going to a difficult place, doing something very technical, and it takes every bit of focus you have to do your work. Never mind all the other stuff. So yeah, I would always highly encourage finding a great on the ground partner.
And that ties into the latest question that has popped up on our Q&A here is logistics. What's your most memorable improvised field piece of equipment that you've developed on the fly to help you do your work?
Yeah, no, there's been a lot of them. but yeah, I guess I would certainly say the kite cameras. So I was in Aceh for 6 months, beginning April 2015, and part of my initial work was going all over Aceh province to all the small towns and villages, and I could only take 15 kilograms of equipment with me on a helicopter, and these villages had nothing. They had no food, no place to sleep. I had to take a water level meter, sample bottles, a little bit of food, camera, notebooks, and whatever I needed to survive. And I wanted to take aerial imagery. So yeah, I went back to the very detailed science of kite photography as developed by the Germans, the British, and the French for World War I for targeting the new invention of artillery, and built my own systems, and it was fantastic. And I just have some amazing images that even with drones now, of course, you'll never be able to recreate those images that I have from the tsunami.
Okay, we're well beyond our appointed time, and this is a great conversation, and I've got maybe one or two more. You have mentioned websites, and I've mentioned, we have mentioned programs and Médecins Sans Frontières. How does a young person find a mentor in this space?
Yeah, no, that's a good question. I think you find find not an agency, you find a person within an agency, whether it's you find an agency that fits technically, I guess I'd say technically what you want to do, which, let's say it's in the water sector. But also, I would say it's also important philosophically what you want to do. So for instance, me personally, I will not work with any kind of proselytizing, any kind of religious type of organization, for instance. And then maybe regionally, the country you might want to work with. And then you track a person down, and you try to get involved as a volunteer, or or in a paid position, or in an internship, and you find out, and if you can't, you find out why you can't, what do you need, what kind of experience, what kind of background, you know, just persistence and obstinance. And like I say, opportunity does arise, you take it. So again, surprisingly, the need is there, but this whole aid industry, it is a bit of a closed shop that's difficult to crack if you're not a professional humanitarian aid worker.
Right. And now, of course, we've got to finish up by bringing in Hollywood, okay? You, of course, mentioned Hollywood in your presentation for the northern Kenya area. And there's a lot of, shall we say, noise coming in from various sectors. There are, as you said, religious groups and foundations and NGOs and Hollywood actors, etc. And I know there's no easy answer on this, but the question is, you know, how can one sort through all of this noise to find those people that are actually doing good, appropriate work, maybe on the ground, and that we could learn from, that we could approach to be mentors, you know?
Yeah, no, that's definitely a good question, and you know, I imagine everyone out there has heard some of the statistics, like in Haiti, all the billions of dollars that went there for housing, and the handful of houses that were built, and you know, I can honestly say in Aceh, for instance, I can honestly say I never saw any corruption, but I can also honestly say I saw hundreds of millions of dollars just, I mean, I was the only hydrogeologist there for UNICEF, just looking at the water, and there were 14 accountants like checking my and that kind of thing. So there's a lot of inefficiencies for sure.
Well,
how do you figure out what's worth pursuing, who's doing good work, who's doing bad work? I think reading, getting in touch with people through, you know, either first person or second person observations. And there are, I can tell you, there is some good information now coming out from within the humanitarian sector. I think there's one weekly called the Humanitarian, and it's called the Humanitarian Digest, and it just shreds the good programs from the bad programs. And there's more and more transparency that's coming out, not much out of the mismanagement of funds, but because of the problems, for instance, publicized with sexual violence and things as extreme as prostitution rings and mismanagement of funds. All these NGOs, all these UN agencies. I'd even say that's one of the few good things Donald Trump did. He put a microscope on the UN. There's more and more transparency. There's information out there, so you can make decisions. And then again, I guess I would say you find out what fits your skill set and what's important to you. And I will tell you that the Angelina Jolie School and Angelina Jolie, and I heard this directly from a geophysicist from Laurentian, where I gave my first talk. He was a lost boy. He'd spent 10 years in the refugee camp. He got out, he hosted Angelina Jolie. He's now working as a geophysicist with an MSc degree in Western Australia. He got a scholarship to U of T and then to Laurentian, and he said she was amazing, and the school there is one of the best initiatives anyone ever did in the Kokuma camp. So there are some great things being done by some of these people.
Right. Well, on behalf of the Water Institute, the University of Waterloo, my department, the Department of Earth and Environmental Sciences, the people who have listened, and we got up to about 44 participants. We still have 26 online. I'd like to extend my thanks to you. I believe that you have agreed to provide a copy of your presentation to the Water Institute. And you did, I think, allow us to record this presentation. And again, I'm blown away by the experiences you've had. It's just tremendous. So on behalf of all of the people that helped make this happen, the Exploration Geophysicists Society, everybody, thanks very much, Paul, and welcome back home.
Thanks a lot, Maurice. Thanks for being such a great host, and I truly, there were a couple places I absolutely wanted to give this in presentation, Waterloo being one, and hopefully I will get there in not too distant future in person. So thank you for everyone for listening in.